So we're looking for the equation of the tangent line to the graph at a specific point. In this case, the point is 2. So this point here, we're looking for the equation of the tangent line. So we need to find the slope at that point. Take the limit as h goes to 0 of f of x1 plus h minus f of x1 over h. There's a few different ways to do this. This is the definition of a limit at a specific point, and we can use this point x1 to be 2. So if we do that, we'd have the limit as h goes to 0. There's a lot of algebra here. So we have 4 minus 9 times the quantity 2 plus h squared minus 4 minus 9 2 squared all over h squared. The general equation of the derivative, instead of x1, you would just have x's. So you would actually have an expression in terms of x. Here you're going to have an expression in terms of h, which would give you the value of the slope at one specific point, in this case, x equaling 2. So if I do some algebra here, I end up with 4 minus the quantity 9, 4 plus 4h plus h squared, minus, and then this is just one number. So we'd have minus 32, but since there's a negative out front, it makes it plus 32 all over h. We're eventually taking the limit as h goes to 0, so we have to cancel this is h squared. We have to cancel an h in the numerator, and you can see here, what are we doing? So we have 4 minus 36 minus 36h minus 9h squared plus 32. So 4 minus 36 would be minus 32 plus 32 over h. And if I factorate an h in the numerator, I get the limit as h goes to 0 of minus 36 minus 9h over h. The h's cancel, and if I let h go to 0, I get minus 36. This tells me the slope at this point. Once we do a little bit more in depth of calculus, we take the derivative of the function, which would be minus 18x. Now if I evaluate that at 2, I get minus 36. So eventually there are shortcut methods here. This is the definition of the limit, plugging that in. So we're wanting to say we're taking this point and some point close to this point, and we're letting that distance be h, and h is going to 0, so we're looking for the slope at the specific x equals 2. So this is the computation. This is the calculus. This would be college algebra approach on the left, and on the right would be the calculus approach. Would be take the derivative of the function and evaluate it at the point. And then in college algebra, we are very interested in the slope at the equation of the line. So once we have the slope and a point, right, we have the point 2 minus 32, and we have the slope minus 36. So the equation of the tangent line would be y minus y1 equals m times the quantity x minus x1. So putting that in there, I get y minus a minus 32 equals a minus 36 times x minus 2. So be really careful on your negatives here, because we have a negative 36, right? And then we have a minus 2. So really this is y plus 32 equals minus 36x plus 72. And if I subtract 32 from both sides, I end up with y equals minus 36x plus 40. So this is the equation of the tangent line of the function at the point x equals 2.